Let's look at MnO2, that is manganese dioxide. Manganese oxide, also known as manganese dioxide. Then we have HCl, hydrochloric acid. I'm sure most of you guys know of this. Then MnCl2, that is your manganese chloride. Yeah, manganese chloride. Or these are the two names. And H2O and Cl2, you guys know it, chlorine and water. So is it balanced? Let's have a look. So we have MnO2, the reactants, HCl. So we end up with MnCl2, H2O and Cl2. Now we have manganese, oxygen, hydrogen, chlorine. I think that's it. So let's map it. So we have here, since I have some space, let me do it here itself. Okay. So this is 1, this is 1, this is 2, none and none. That is MnO2 has 1 magnesium and 2 oxygen. Sorry, 1 manganese and 2 oxygen. Then we have none and none, 1 hydrogen and 1 chlorine. Then we have 1 manganese, none and 2 copper. Sorry, chlorine. None, no, not none. Oxygen is 1 over here, hydrogen is 2 and none and 2. So let me explain what I did. If you guys are watching only this video, you should not be. You should watching the basics and then this video. Now what I did here was I wrote all the reactant in the product at the top. Okay, then I'm going to put a line to differentiate where the reactants are there and products are there. And then I wrote all the atoms that are involved in the reaction. And I mapped the number of atoms in each of the compound. So in MnO2, there is 1 Mn and oxygen is 2. Agree? Just have a look at it. Okay, everything is okay now. Have I mapped it properly? So we have 1 oxygen, 2 hydrogen, 2 chlorine, then 2 chlorine over here, so on and so forth. Now, are things balanced? Clearly, they are not. We have chlorine to be 4, so chlorine here has to be 4. Since for this chlorine to be 4, HCl has to be 4. See, for every pair of HCl, there is 1 chlorine atom. For 4 pair of HCl, there will be 4 chlorine atom. Is that right? Think about it. That's the very first step. If you understand that, only then it makes sense. If not, the next sequence of steps will not make sense. I hope you guys thought about it. In 4 pair of HCl, there will be 4 hydrogen atom. Right? So chlorine is balanced. Hydrogen is not balanced over here. On the RHS, there is only 2 hydrogen atom. So I'm going to multiply 2 over here to balance it out. So this entire thing has to be 2. Only then we will have 4 hydrogen atoms. H2O. A pair of H2O. H2O and H2O will give us 4 hydrogen atoms. Is that correct? Since we are taking 2 water atoms, right? So pair of water molecules, compound, we have 2 oxygen as well. H2 and H2O will give us 2 oxygen atoms. Now let's look at it. I think it's balanced now. Your manganese is balanced, oxygen is balanced, hydrogen is balanced, and chlorine is balanced. And this is your, yes, balanced equation. MnO2, this is a solid. HCl is correct, aqueous. And this gives us MnCl2, 2H2O. That is, of course, liquid. This is actually aqueous. I should have given some space. And finally, we have Cl2, that is gas. So what are the indicators? Clearly, there is gas formation. And this is exothermic, right? So we have heat as well. There is color change in the solid and the liquid. So let's indicate all of that. So how do we get to know the reaction has happened? First thing is your gas formation. So this produces a greenish, this we'll see in experiment, yellow gas. That is pungent. I like this kind of smell, but yes, irritating odor. Okay, yes, that is nothing but your chlorine gas being produced. So your color change in solid. So you have your manganese. So let's start off with this. This is a black, if not dark brown. Solid, which will gradually, actually it will dissolve. Is it not? Then we have color change in liquid. Once it dissolved, what happens? There has to be some kind of change in liquid as well, because it also is becoming aqueous. The resulting solution will become, I think, if I remember right, it's pale pink or colorless. If it's dilute, then this is how it is. If not, it will get pale pink. I remember this color. And of course, finally we have heat that you guys can write. Now, let's look at the oxidation and reduction. That's pretty important over here. So first we'll start off with, oh yeah, I do want to talk to you guys about the manganese and what else? We have hydrogen. Then we have chlorine, oxygen. Then we have manganese. So did I list it over here? So, okay, look at the valencies. Look at the manganese valencies. That's so weird, right? Again, transition metals, they show all of this behavior. We need to understand those. Go back to basics for that. There's a lot happening over here. Just have a look. Okay. Now let's move forward. So we are looking at reduction. Now reduction has to do with, yes, gaining of electron. MnO2 contains 4 plus. Again, let me write before and after, that makes more sense. Let's start with before and then after. Only then it makes sense, is it not? So initially, what is that we are looking at? Think about it. I'll give you guys a clue. We went from MnO2 to MnCl2. Okay, so I want you guys to map it with the table. Next clue is look at the valency. Think about it. So we went from, or manganese went from 4 oxidation, state to 2 oxidation state. What does it mean? So it gained electron. Since we are moving from 4 to 2, how is this possible? It gains or gained electron. Why is it gaining electron? Look at the valencies. That will give you a picture. Oxygen wants 2, while chlorine wants 1. It wants 2 electron. It wants 1 electron. So what is that we are looking at? MnO2. So O2 needed, yes, 4. While this needs, Cl2 needs 2 electron. So it needs 2 electron. Here it needs, sorry, not 2, my bad, 4 electrons. It needs 2 electrons. Again, go back to the valency. It should make sense. Go back to the valency. So it gained electron and thus it got reduced. Does it make sense? Again, everything is quite simple, guys, provided you understand from the basic. Then oxidized. Who is getting oxidized? Who is getting oxidized over here? Think about it. It's quite simple. Yes, chlorine. Let me start off with before and after. Before and after. Now, before, what is happening? We have HCl. It moved from HCl to, we have Cl2. Think about it. How is this possible? So initially here it is Cl minus. It's in chlorine ion, is it not? That is, it has a charge of -1. In Cl2, this is nothing but neutral. So it went from -1 to +1, sorry, 0. This implies, let me write the implies symbol over here. Yes, it lost an electron and so it is oxidized. In HCl, chlorine will pull the electron, thus becoming negative, right? Chlorine, where is chlorine? It's over here. It pulls the electron from hydrogen and it becomes negative. Is it not? And when all of this reaction happens, then you have Cl2, right? Chlorine gas. And Cl2 means it is neutral. It's sharing and all of that. It is non-polar covalent. So it lost electron. From negative to 0 means what? It's losing electron. And this is nothing but an oxidized form. Okay, guys. It's quite simple. If you understand this set of tables, this set of values, then this will make sense. If not, you're just memorizing. Don't do that. It might feel a bit difficult to not memorize and understand and then, have a comprehensive overview of all of this and then bit of memorization. That might take a bit more time, but that's the right way to go about it. It will help you in the future.